Alrighty, last video, here we go, number 4. I've graphed the parent function for tangent, just like we graphed in number 4. So let's go together through our transformations. Our parent function, again, is tangent of x, which I have graphed to the right. There is no reflection. A is positive. Amplitude, again, we don't have one. But we do see here that there's this 2. So what we say is that there's going to be a vertical stretch of 2. So that's basically the same thing as an amplitude change when there is an amplitude, but with tangent functions there is no amplitude. Horizontal shift, no numbers being within parentheses, so no, and there's no k value, so no. So this is the only thing we have to do is figure out how are we going to vertically stretch this graph. So visually we can picture a vertical stretch. We're going to pull on the ends. Okay, so it's going to become steeper. But basically what happens is we basically evaluated tangent of x, which are these values here. And then in the end, you just multiply by 2, right? We plug in the same values for x, figure out that tangent value. So for example, at pi over 4, tangent of pi over 4 is at 1. But now you're taking your output and you're multiplying it by 2. So this point that used to be at 1 is now going to be at 2. So that goes for all of these points that were at 1 are now going to get stretched to 2. Likewise, if we went to negative pi over 4, tangent's equal to negative 1, but now we're going to multiply by 2, so it's going to get stretched to negative 2. So all of those points get stretched down. And for values like 0, tangent of 0 is 0, times 2 is 0. Those points stay put. So if we do a quick sketch of that, it's very slight, but they are a bit steeper. So there's our, probably the best thing to do would be to label some points. So I would at least label at least 1 or 2 of these periods. So something like this. So this is pi over 4, 2. This point here was negative pi over 4. Oh, geez. Sorry, guys. Negative pi over 4, and it was down at negative 2. So how about on the tangent functions, just to be fair, label at least, in this state at 0, 0, label at least 3 points on one of the periods. So you could do the same thing here. So here we had 2/4, so at 3 pi over 4 is at negative 2, and 5 pi over 4, it was at positive 2. So you could pick any of those periods and at least label 3 of those points. We'll call that good. And the domain, all real, all real except our asymptotes, which in this case are the same that we had last time. So all the odd multiples of pi over 2, the range is all real. All right. Have a great weekend, you guys. Come Monday prepared to take a quiz where we'll have 4 graphs. Also, if you have not printed out the homework for this weekend, it's on my blog as well. There are 4 graphs on the front, 4 graphs on the back for you to practice graphing. We'll take some quick questions probably at the start of class, but if you feel like you have more than a quick question, definitely come in earlier and we will go over it. So enjoy your weekend. Finish Khan Academy if you haven't done so already, but overall good job these last couple weeks. I know it's been kind of tedious graphing, but these are definitely new graphs that you guys have never graphed back in algebra or advanced algebra, so we needed to slow down and take it slowly. Have a great weekend.